Hello! Today we are going to look some more at our rational functions that we've been dealing with. So far in this unit we've solved rational equations, we've simplified with the operations with rational expressions, but we haven't seen where we're going to use this. And I know what you're thinking. You're like, oh, there is even no point to this. Why is Mrs. Freeze teaching us this? Does she just want to torture us? And no, I do not. And there are good uses for this. So that's what we get to see today. So that's very exciting. So I want you to pull out the packet, or the paper from your packet that looks like this. It just says warm up at the top. So it doesn't really have a good title on it or anything. But so this is what you need to pull out. Also, some of the parts copied terribly. I'm so sorry that those are hard to read. So what I did was I looked through the dark part and tried to figure out what it said, and I typed them on your Canvas page here. So the ones, when you get to the ones that have the dark background and you're like, oh, I can't even read that, it's over here for you. So you can look and see what it says here. So I have that for you. So what I was thinking is we would go through some of them together and then you can do some of them on your own. So the first set I want to look at is at the very top of the page here. So fill these in with me. This will be like your notes for the day. And then when you submit it, you'll have them all done. So I kind of feel like they should have asked these questions in reverse order. So I'm going to start over on the right where it says, what happens when you divide one whole by a really big number like 1,000? So hopefully you can see that. Let me see if I can move this down at all. Case it under my picture. There we go. What happens when you divide one whole by a really big number? So let's try 1 divided by 1,000, since that's what they mentioned. That's 0.001. If I take 1 and I divide it by 10,000, whoa, I get an even smaller number. If I take 1 and divide it by 1,000,000, 1, 2, 3, gotta get the right number of zeros on. Oh, I get an even smaller number. Okay, so when you have a fraction, you have 1 over something. The bigger that denominator gets, the smaller your fraction is going to get. It's going to get closer and closer to 0. Think about a pizza. If I have a pizza and I'm going to split it, just you and me, we get a pretty big section of pizza. If I have a pizza and I'm going to split it with like 25 people, we each get like a little piece. If I have just one pizza, same size pizza in all of these examples, and now I say I'm going to split it with like 1,000 people, you're like, don't bother, I don't need a crumb. So the bigger the number gets that you're dividing by, the smaller your fraction gets. So it approaches 0. So you could fill that in this third box here. Now let's talk about the one in the middle. It says, explain why 1 divided by 0 equals y is an impossible number sentence. And to do that, I would like to think about what is dividing anyway. So, like, let's say you had 12 and you were going to divide it by 3. What would you get? Well, 4. Yeah, you would get 4. And the reason for that is because 4 times 3 equals 12. So you can take the answer and multiply it by what you're dividing by, and that gives you the number that you started with, right? So let's do another one of those. Let's erase. Oh, wait, that's not erasing. What if I asked you, what is, I don't know, 30 divided by 5? Well, that would be 6, yeah, because, and your reasoning would be because 6 times 5 equals 30. You would take the answer and multiply it by what you're dividing by, and that would get you back to the number that you started with. So that's the reasoning of how we know a division problem is correct. You check it with multiplication. So when you see this sentence that says 1 divided by 0 is supposed to equal y, well, if it equals y, then I should be able to say that that answer, the y, times what I am dividing by, the 0, will equal 1. So that should be the multiplication fact proof that we can connect to this problem. However, we have an issue here because what happens when you multiply by 0? Anything that you multiply by 0 always turns out to be what? Yeah, 0. So there is no possible way you can get a number 1 if you have something that you're dividing by 0. It doesn't work. Doesn't make sense. So that's why that's an impossible number sentence. Now the first question here listed is the one I feel like they should have done third. It says, what happens when you divide one whole by a really small number, like a 1 over 1,000? So I'm going to type this in my calculator. 1 divided by, and then I'm going to put parentheses, 1 over 1,000. And I get 1,000. What if I do 1 divided by 1 millionth? So 1 divided by teeny tiny fraction. I get a bigger number. So when you divide by something small, your answer becomes very large. So that's what they're going for here in the warm-up. So I thought we would do 2 of these problems together. So one of the ones I want to do with you is the mixing lemonade problem. So if you could find this one in your list of them. So it says you mix together some lemonade mix and some water. There are 5 liters of this mixture, and it is 75% lemonade mix. You taste it, and it is way too sweet. You start adding more water. If you add X liters of water, what is the concentration of the new mixture? Okay, so like you can get this lemonade mix stuff at GFS, and it's like super concentrated, like way more than the frozen kind, where you just add a couple of cans of water. Like this stuff is like strong, okay? And if you don't add enough water, it's terrible. It tastes awful. So that's what's going on here, okay? So you've mixed it. You have 5 liters of this mix, and 75% of that is the lemonade mix, okay? So let's see how much of that would be. So I'm going to take 75%, 0.75, and multiply it by the total amount that I have, 5 liters. Okay, so I got 3.75. So what that means is there is 3.75 liters of the concentrate, and then, see, that would leave 1.25 liters of water that you have put in so far to make this 5 liters that you currently have. Okay, so you started with 3.75 liters of concentrate. You've added a little bit of water, but not even close to enough. Okay, you taste it and it's terrible. So we're not going to add any more lemonade concentrate to this because it's already too strong. So the only thing we're adding to it is water. So right now I could check the concentration by taking the 3.75, the amount of lemonade, and dividing it by the total amount of fluid that I have, which is 5, and I get a 0.75. So that verifies what we know, like how we got that number. So if I don't add any more water to this, then I am going to have a 75% mixture. So I could do the decimal form of this, but I think it'd be better for us to use the percentage. So I'll move the decimal over 2 places and call that 75%. Now, if I add a liter of water, I'm still going to take the 3.75. So I'm going to write this down here. It's not really the equation yet, but it's getting me thinking that way. I'm going to take the 3.75 liters of the concentration and divide it by, now what will be my total fluid in this bucket? Now I had 5 liters and I'm adding another liter of water. So now there's 6 in there. So I'm going to take the 3.75 and divide it by 6. So 3.75 divided by 6, and I get, okay, so now it's 62.5%. Okay, so it's getting less strong, which makes sense because I'm adding more water to it. So now if I add 2 liters of water, so remember we were at 5 liters when we started talking in this problem, so I'm going to get rid of this denominator. The 3.75 is not changing here because I'm not adding more lemonade to it. I'm just adding more water to dilute it. So it won't add to the concentration, it'll just add to the total. So now I did have 5 liters, and in this box I'm adding 2 liters of water, so that means I'll be dividing by 7. So I'm going to put a 7 down here and take the 3.75 and divide it by 7, and I get, looks like it's about 50, we'll round it to 54%, okay? It's a little bit off from that, but that's fine. We're just talking about lemonade. We're not talking about rocket science. It's okay to round. So now I am going to add 10 liters of water. Now, remember we had 5 to begin with. We're going to add 10. So now that means there is 15 liters total in this pitcher or bucket or whatever we're mixing it in. So if I take the 3.75 and divide it by 15, I'm getting, now it's only 25% lemonade mix. So, and at some point I think this is going to get too weak. I don't know what the right ratio would be on this, but so the next one, I'm going to need to add 20 liters of water. So what's going to be my denominator down here? So now I want you to think about what we do every time. So we always have 5 liters to begin with, and then what do we do with this number, this 20 in this case? Well, we add that, right? So our equation here is going to have a 5 plus x in the denominator, where x is the amount of liters that we're adding. We always have 5 liters already, and then we add to that. So we're adding x in our denominator. So anyway, let me do the one with the 20. So 3.75 divided by, that would be 25. And that gives me a 15% mix. If I add 100, 3.75 divided by, so I'd have to divide by 105. Now it's only a 3.6% lemonade mix. So at some point this stuff is going to be too watery. I would guess that would probably be too watery. But now if you add 1,000 liters of water, you're not even making lemonade anymore. You're just making flavored water. So I'm going to divide by 1,005. And oh my goodness, it's so small. It is way under 1%. It's like 0.004 approximately. So it's, I don't even know if our taste buds would be even able to tell that it's not just water at that point. So what happens to the concentration as more water is added? And it goes down, it decreases. Because you're watering it down. As you add water, the denominator is larger. Denominator gets larger. Okay, so then we need to come up, does this one need graphed? No, okay, so this one does not need graphed. The next one I believe will need graphed. So that finishes that problem. Let's look at number 5, planning a party. And then you have a couple of others that are kind of like this, because you have like a dance and a, I don't know, something, prom or something, I don't know. Anyway, so this is one that's really hard to read, so you can go read it over on the Canvas page if you would like to, or I know what it says, so I'm going to read it. It says, you are planning a party. The location you rent costs $300. The food costs $10 per person. There are 20 special guests who will not need to pay, but they do need to eat. The cost will be divided evenly among the remaining guests. What is the cost per guest? Okay, so you have 20 people coming that you are not charging for. You're not making them pay, but the caterer and the location is still going to make you pay for them. Like, the caterer is like, okay, fine, you can have them not pay, but then you owe me for it, you know? So the caterer still needs their money for feeding these people. You're just going to make the other guests pay for these 20 special guests, okay? So that's what's going on here. You have 20 special guests that are not going to chip in, okay? Now, so in this chart here, if you have 25 people who are coming, and that's including the special guests, the 20 special guests, how many people have to actually pay for this meal? Well, only 5 of them do. Okay, so I'm going to do this. I'll do this off to the side, I think. So we're going to divide it evenly among the 5 people that are actually going to be paying guests in this first example that we're working with here. Now, how much money is this event going to cost? Well, how much does it cost just to rent the hall? Like just to get the location? You see it? Yeah, that's $300. So I got to pay $300 up front. Plus, there's also cost for the food. And the food is $10 a person. You got to pay $10 a plate, basically. So that means I got to know how many people are coming. So in this example that we're working on, we have 25 people coming who are all going to eat. So 25 people at $10 a plate is 250 people. So if I add that 300, that's a little hard to read that that's a 300, but that says 300 plus 250, that would be 550. And if I'm going to divide that by 5 people, sheesh, we're going to be charging $110 to each of those 5 people because they're carrying the burden for all of these free guests. So that's not good. A little steep. So the more people you can get to come, the less everyone's going to have to pay. So let's look at this next example. So let's say we have 30 people coming now. So the hall is still going to be $300. So, oops. Okay, so the hall is still going to be $300. Plus, I still got to pay for food. Only now I got 30 people coming. And remember how it's $10 a plate? So that means that food bill is going to be $300 because if more people come, they have to eat. But now, how many people do I have to share the cost? So there's 30 guests, but remember 20 of those are special guests. They're free. So how many are actually paying for the event? Well, that would be 10 people left to pay for it. So that'd be 600 divided by 10 is $60 a person. Okay, so still kind of pricey, but the price is coming down. Okay, so let's try 40. So I'm color coding this so you can tell what goes with which numbers. So the hall is still going to cost $300. I got to pay for food. Now there's 40 people coming at $10 a plate, so that's $400. And then how many people would I be sharing the cost with? So remember, 20 of these are the special guests. So if there's 40 people in the room, that leaves 20 of them to share the cost. So my numerator, 300 plus 400 is 700. And I'm going to divide that by the 20. That's $35. Okay, so the price is definitely coming down here. So I'm going to, well, actually, I think let's write the equation next. And then we'll fill in the rest of the table. So if you notice these equations, I'm going to start out with a y equals. What number do I have to pay every single time for the hall, for the location? That is $300 for sure. Now, the next part, the food part, it changes based on how many people are coming, right? So how much is it costing for every person? A plate? Yeah, it's $10 a plate. So I'm going to put 10x here because when there were 25 people coming in the purple, I had to pay $250 for the food. That's that second number of my numerator. When there were 30 people coming in the green, I had to pay $300 for the food. When there are 40 people coming, I had to pay $400 for the food. So I always have to pay $10 for every person who comes. Now, who shares the cost? How do I get this denominator of what's sharing the cost when I'm looking at x as my number of guests? So like, look at the purple. When there were 25 people coming, why did I divide by 5? How did I get the 5? Well, it hinges on those special guests that aren't paying. How many people are not paying every time? 20? Yeah, there's 20 people not paying. So it's always however many guests are coming minus 20 because those 20 aren't paying. So I'm going to say x minus 20 for my denominator. So that is your rational function. So I think you will be able to finish out the rest of that table then. Let's look at what the questions are. Excuse me. Okay. So as the number of guests gets bigger and bigger, the cost per guest approaches. Okay, so to answer this, I want to skip ahead and do the 200 with you. So I'm going to feed that 200 into my function here. So that means 300 plus 10 times 200 is 2,000. So $2,300 is my numerator. And I'm going to divide that by 180 people. So now it's down to only costing $12.77 per person. So the price is definitely dropping. Now I'm wondering what it's dropping to. Like how low could it possibly go? And it has to do with, I want you to look at the degrees of the numerator and the denominator here. 10x, that would be like an x to the first. And this x in the denominator is also like x to the first. So we have a tie in the degree of these. And so what we look at is the coefficients in front of those numbers, the 10, and what would be an understood 1 in front of that x in your denominator. So 10 divided by 1 is 10. So this is getting closer and closer to $10. Because if you have lots and lots of people, like let's say you invite 1 million people to this party. I don't know how you would actually do that, but invite a whole lot of people. They're only going to have to toss in like a couple of pennies to cover the cost of the hall, but they are going to have to still pay for their food because every time another person comes, that person's going to eat. So they're sharing the cost of the other stuff, the hall, but they got to pay for the food. So it would approach $10. The cost approaches $10. As the number of guests approaches 0, your cost per guest approaches. Okay, so this is a question that like I feel is a little weird. I know what they're going for. They want you to say infinity here. Okay? Because let me graph this for us real quick. Over here on Desmos. So it is y equals, and it was 300 plus 10x over the x minus 20, right? Okay. Okay, so here's my graph. So I know what they're going for. They want you to see that this has a vertical asymptote that's going up very, very high. However, it's not really going to make sense to say that it approaches 0 people because you have 20 free people coming. So I don't really like that question, honestly. So you can put infinity, but it doesn't really make sense to say it's gonna cost infinity because it doesn't make sense to say you're gonna have 0 people come when you have 20 special guests that were supposed to be free for them. So it's kind of a bad question. I think they should have said as the number of guests approaches 20. What if nobody except for the free people come? Well, then you're going to have issues because nobody's going to say that they're paying because they're all special guests. So anyway, there's that. Sometimes math questions, when you put them in a context, make a little bit less sense than they do when they're just purely hypothetical math. So even though it would approach infinity as you went down to 20 guests, it's weird the way that they have it. So there is that. So you are going to do these other questions on here. So you have one about distance for a 100-mile road trip. Okay, so you're going 100 miles. So on that, think about the fact that distance equals rate times time. And you can solve for a different variable if you would rather not have the d be the one by itself. It's probably what will help you here. So there's that. Ticket prices. Okay, so this is similar to the one that we just did, but there's no special guests. So everybody who comes pays. So your denominator will be simpler than in the one that we did together. There's the one we did together, lemonade. Here's the party one that we just did together. This one is about a refrigerator. I know that's hard to read, so I have it over on the Canvas page. And then this one is about a holiday dance. So it's very similar to the party one. So I think you will be good with that. So I think that is everything. So remember that Jesus loves you and so do I. So do your math.